Hello, my name is Joshua Kabi. I welcome you to Ionic Chemistry and Qualitative Analysis. We are going to talk about redox reactions. Define the following terms. Define the following terms. We are going to define reduction reaction, oxidation reactions, and redox reactions. Those are the terms that we need to define. A redox reaction, this is a reaction which involves both reduction and oxidation. What we call a redox reaction, it is a reaction involving both the reduction and oxidation reduction. It's what we call redox reaction. Reduction reaction, this is a reaction which involves reduction in charge or oxidation state or gain of electrons. When there is reduction in a charge or oxidation state or gain of electron, that one is called a reduction reaction. We have the oxidation reaction. This is a reaction which involves an increase in the charge or oxidation state or loss of electron. So when there is an increase in the charge or oxidation state, that one is referred to as oxidation reaction or the loss of electron. Explain. When sodium hydroxide is added to freshly prepared iron 2 sulphate, a green precipitate is formed. On adding dilute sulfuric acid, followed by hydrogen peroxide, a green precipitate rapidly turns brown. So they want us to explain that when sodium hydroxide is added to a freshly prepared iron 2 sulphate, we get a green precipitate. And this green precipitate, when we add dilute sulfuric acid followed by hydrogen peroxide, we form a green precipitate rapidly, which turns to brown. Now, the green precipitate which is formed is iron 2 sulfide. Because remember, we added sodium hydroxide to a freshly prepared iron sulfate, which means that sodium hydroxide is going to provide the hydroxide ions and iron 2 sulfate will provide the iron ions. The iron ions will react with the hydroxide ions and they are going to form iron 2 sulfide, which is a precipitate, which is the green precipitate. So here we are saying the green precipitate is iron 2 sulfide. That is the green precipitate formed. Now, in the presence of the acid, hydrogen peroxide oxidizes iron 2 to iron 3 hydroxide. So we saw that here on adding dilute sulfuric acid followed by hydrogen peroxide, a green precipitate rapidly turns brown. Now, iron 2 is the one which is in iron 2 hydroxide, which is a green precipitate. So in the presence of hydrogen peroxide, iron 2, which is green, is oxidized to iron 3 hydroxide. Now the iron 3 is the one which is brown in color. So there has been an oxidation of iron 2 to iron 3. Now, when sodium hydroxide was reacted with iron 2 sulfate, the iron 2 sulfate provided the iron 2 ions, and sodium hydroxide provided the hydroxide ions. Hydrogen ions and hydroxide ions reacted together to form iron 2 hydroxide, which is a green precipitate. So when we formed this green precipitate, which is iron 2 hydroxide, we added there dilute sulfuric acid, which was followed by hydrogen peroxide. So what happened is that the iron 2 ions in the presence of the acid and hydrogen peroxide, it was oxidized to iron 3, and then we also got water. So iron 2 in the presence of the acid and hydrogen peroxide was oxidized to iron 3, and that is the green part. That green part, it is iron 3. The green part is iron 2, sorry. The green part is iron 2. When it is oxidized to iron 3 is the brown part. So iron 3 reacted with hydroxides to form iron 3 hydroxide, which is a brown precipitate. So we were saying that sodium hydroxide was added to a freshly prepared iron 2 sulfate. When we added sodium hydroxide to iron 2 sulfate, we formed a green precipitate, which is iron 2 hydroxide. And on this iron 2 hydroxide, we added there dilute sulfuric acid followed by hydrogen peroxide. The hydrogen peroxide oxidized the iron 2, which is green, to iron 3, which is brown. Iron 3 reacted with the hydroxides to form iron 3 hydroxide, which is a solid, which is brown in color. Explain. When chlorine gas is bubbled through potassium iodide solution, the colorless solution turns brown. You have to explain why, when chlorine gas is bubbled through a solution of potassium iodide, we get a colorless solution that turns brown. Chlorine is a strong oxidizing agent. Chlorine is a strong oxidizing agent. When you look at chlorine, is a strong oxidizing agent. It oxidizes iodide ions in solution, forming iodine. It oxidizes iodide solution, its solution forming iodine. You know, chlorine, iodine, bromine, all those ones are halogen. And the oxidizing power reduces in the order as you go down the group. Chlorine is on top, followed by bromine, and then iodine down. So chlorine is the strongest oxidizing agent, followed by bromine, and then lastly by iodine. So which means that now starting from down going up, that is reducing. Iodine is a strong reducing agent, followed by bromine, and then chlorine is the least. So that's how the trend is. Oxidation decreases as you go down the group, and reduction decreases as you go up the group, meaning that the oxidizing power goes on reducing in the order of chlorine being more oxidizing agent, followed by bromine as an oxidizing agent, and then followed by iodine. Therefore, the reducing power of halide ions is in the order of iodide ions have more reducing power, followed by bromide ions, and followed by chloride ions. So that's how it is. But in terms of the gases, chlorine gas is a strong oxidizing agent, followed by bromine gas, and then lastly iodine. So when chlorine is passed through or bubbled through potassium iodide, a solution, chlorine is going to oxidize the iodide ions to move away from potassium, and then they will turn into a solution of iodine, which is going to turn into brown. So we have chlorine gas. When it is bubbled through a solution containing iodide ions, it is going to oxidize. And oxidation, we said, is the removal of electrons. It is the reduction in the oxidation state. So here you will see that the iodide ions are having -1. So they are going to be oxidized. And when they are oxidized, they are going to lose the electron from -1 to 0. So it has been oxidized. The oxidation state has increased because it has lost an electron to chlorine. Chlorine has been reduced and iodine has been oxidized. Explain. When zinc dust is added to copper 2 sulfate, a blue solution gradually turns to colorless. When you get zinc dust and add them to copper 2 sulfate solution, the blue solution of copper 2 sulfate solution gradually turns to colorless. So we have zinc being higher than copper in the electric reactivity series. Therefore, zinc can reduce copper to ions, forming copper metal. Therefore, the blue color of the solution is due to the presence of copper to ions. But as they are removed, the solution turns to colorless. So what is happening is that now zinc being higher than copper in the reactivity series, zinc can reduce copper to ions from forming a copper metal, from the solution to form a copper metal. And when it forms a copper metal, meaning that it is gaining more electrons. When it gains more electrons, it loses the blue color in the solution and it turns into a metal. And that's why the solution becomes colorless, because we have removed the copper to ions. So zinc, which is a solid, is going to reduce copper to ions, and then zinc will be oxidized to zinc to ions and copper reduced to a solid. So the solution now has no copper to ions, which make it to be blue, but they have been reduced to copper. Therefore, the solution now becomes colorless. Study the flow chart regarding analysis of a solid. Study the flow chart regarding analysis of a solid. So we have our flow chart. We have solid P. When it is dissolved in water, it forms a colorless solution, Chu. This colorless solution, Chu, when we add few drops of sodium hydroxide, we get a white precipitate. And this white precipitate, when we continue adding excess sodium hydroxide, we get a colorless solution R. When we dissolve the P in water, it formed a colorless solution. And that colorless solution, when we added a few drops of potassium iodide, we got a yellow precipitate. And P, when was heated, it formed brown fumes. So this is our flow chart. It's made up of solid P. When heated, it forms brown fumes. When dissolved in water, it forms a colorless solution. That colorless solution, when you add few drops of potassium iodide, you get a yellow precipitate. And one sample of the colorless solution, Chu, when you add a few drops of sodium hydroxide, you get a white precipitate. And when you add in excess sodium hydroxide, you get a colorless solution R. Now they are asking us to suggest the name of P. What is the name of P? From what you have read from the table, what do you think the name of P is? P is lead to nitrate. P is lead to nitrate. So lead to nitrate, when it is heated, it is going to give us brown fumes of nitrogen dioxide. And lead 2 nitrate dissolves in water to form a colorless solution. Lead 2 nitrate is soluble in water. Suggest the name of the brown fumes. Suggest the name of the brown fumes. The brown fumes, that is nitrogen dioxide. It's the brown fume, nitrogen dioxide. Suggest the name of the yellow precipitate. Suggest the name of the yellow precipitate. Here, when we got our P and dissolved it in water, we got part of that colorless solution, added in few drops of potassium iodide, and we got a yellow precipitate. Now they are suggesting that suggest the name of the yellow precipitate. The name of the yellow precipitate is lead iodide. Lead iodide. Suggest the name of the white precipitate. Suggest the name of the white precipitate, which is this one, white precipitate. What is the name of this white precipitate? The white precipitate is lead 2 hydroxide. It is lead 2 hydroxide. Write the formula of the species in the colorless solution 2. Write the formula of the species in the colorless solution 2. 2 here. Can we write the species, the formula of the species that are found in this colorless solution? The colorless solution is lead 2 nitrate aqueous, meaning that it dissolves to form lead 2 ions and nitrate ions because it is aqueous, soluble. Lead nitrate is going to give us lead ions plus nitrate ions. So those are the ions that we have found in this colorless solution. Write the formula of the species in the colorless solution R. The formula of the species in the colorless solution R. What are those species in this colorless solution of R? Now, the colorless solution of R was obtained from the white precipitate, and that white precipitate was lead 2 hydroxide. When lead 2 hydroxide was reacting with excess sodium hydroxide, we formed a complex which is called plumbate. This one is soluble. It is the one that formed the colorless solution. which is a plumbate. So this colorless solution here is referred to as lead 2 plumbate ions, and it is the species in the colorless solution. Write ionic equation leading to the formation of a yellow precipitate. This is our yellow precipitate. They want us to write the ionic equation leading to the formation of a yellow precipitate. The yellow precipitate. Now this yellow precipitate was obtained after adding few drops of potassium iodide to lead. So we have lead 2 ions reacting with iodide ions to give us lead 2 iodide. Lead iodide, which is a yellow precipitate. Write ionic equation leading to the formation of white precipitate. This is the white precipitate. It's also coming from lead ions. How did it form a white precipitate here? So the lead ions from here reacted with few drops of sodium hydroxide, and they formed a white precipitate, which is lead hydroxide, which is a white precipitate. Hello, thank you very much for participating in ionic chemistry and qualitative analysis. We have been talking about redox reaction. Thank you.